So hello brother. So looking at this second question, yeah, we are asked to determine the system function h of z. So to get this frequency response, which is h of z, so the first thing we will do for this system is that it is already in the discrete form, that is h of n. So solution to this is h of n is equal to 1 all over 4 raised to power n cos pi all over 4n, you know, u of n. And we know that cos omega is the same thing as half e raised to power j omega plus e raised to power minus j omega. We know that, right? So if we know this, so we can simply insert this into the system. You can simply insert this into the system. So h of n from here is equal to 1 all over 4, everything raised to power n, e raised to power, that is, first of all, put the half there, half, then e raised to power j pi all over 4 n, right? Okay, so plus e raised to power minus j pi all over 4 n, right? So u of n. So this is going to be, so if we expand this, like if for instance we expand this bracket now, we can bring out this half. Then when we bring out this half, then this 1 all over 4 is raised to the power of n. If it multiplies this, they both have raised to the power of n. So we can bring them together as 1 all over 4, right? 1 all over 4 e raised to power j pi all over 4. Then all raised to power n, right? We can write it like this, plus this one also 1 all over 4 e raised to power minus j pi all over 4. Then everything will be raised to power n, u of n. All right. So, but we know that if we want to turn if we want to find the z transform of h of n, h of n, if we want to find h of z is going to be, from n equals to 0 to infinity of h of n itself, then 0 is to the power minus n, right? So this is the formula for finding the impulse response of the system, and we can just apply that to this and apply it to each term in the expression. So h of z from here is going to be half. So we're applying the z transform to everything here, right? So we can put it there, n from 0 to infinity. Then we apply it to this everything here. So this is going to be 1 over 4 raised to the power j pi over 4. Everything raised to the power n is 0 raised to the power minus n. Then plus this one also, 1 over 4 e raised to the power minus j pi over 4. Then 0 raised to the power minus n. So this is n, right? So you know you are fine again. So we have converted it to z transform as it is like that. So this one as it is going to be half. We can combine these two together like this. So this is going to be, it's going to be n starting from 0 to infinity. So 1 all over 4 e raised to the power j pi all over 4. Since they all have the same power, so we can bring the z inverse into the system. And this is also the same thing we apply to this. Pi all over 4, z raised to the power minus 1. Put everything there. Everything raised to the power n, right? So now that we have this expression like this, if we now apply, the formula, that is the formula we apply for sum to infinity, sum to infinity. If, like, sum to infinity now, that if we have, we want to sum to infinity of a raised to power n, is going to be 1 all over 1 minus a, right? So n from 0 to infinity. So we are applying this formula as well. So we are applying it that. So that's what we are going to do to this one too. So in this case, it's going to be 1 all over 2. So put everything together, it's going to be 1 all over 1 minus 1 all over 4 e raised to the power j pi all over 4 z raised to the power minus 1. So which is of course the z transform of this expression. And this is also going to be 1 all over 1 minus 1 all over 4 e raised to the power minus j pi over 4 z raised to the power minus 1, right? Okay, so this is what we get from here. So at this point now, what we now do is, so what we now do from here is that we are going to combine these two fractions together. We have, when you this one multiplies this, we have 1 minus, it's like we are finding the LCM of this fraction. That is 1 minus 1 all over 4 e raised to the power j pi all over 4 z minus 1, and 1 minus 1 all over 4 e raised to the power minus j pi all over 4 z minus 1. So this and this is going to cost this, you are left with this. This will now multiply 1, and that's when you have 1 over 4 e raised to the power minus j pi all over 4 is raised to the power minus 1. Then plus, now this also, this and this will cost this, we are left with this, and it will go, going to multiply 1, and you have 1 minus 1 all over 4 e raised to the power j pi all over 4 is raised to the power minus 1. So that's the expression we're going to come up with at the end of the day. So this is going to be 1 plus 1 here is going to be 2, right? So also, these and these now, they have something in common. So the only difference is e raised to the power j. So we bring those common factors out of the expression. We have 1 over 4. So bring this one out. It's going to be e raised to the power minus j pi all over 4 plus e raised to the power j pi over 4 z raised to the power minus 1, right? And this is good. If we expand this, the one at the denominator is going to be 1 times 1 times this term is going to be 1 over 4 e raised to the power minus j pi all over 4 z raised to the power minus 1. This times 1 is going to be minus 1 over 4 e raised to the power j pi all over 4 z raised to the power minus 1, right? Then this times this, 1 over 4 times 1 over 4, that would be 1 over 4 square, of course, 1 over 16. Z raised to the power minus 1 and z raised to the power minus 1, that would be z raised to the power minus 2. Down e raised to the power j power and e raised to the power j minus 1, this one is having minus j, while this one is having plus j. So when the two multiply together, minus and plus become 0. So e raised to the power 0 is going to be 1 eventually. So what we'll be left with here is 1 all over 4 squared and z raised to the power minus 1 squared. So that's what will be left. So that 1 over 4 squared is equal to 16. So eventually this is going to be plus, because minus times minus is going to be plus 1 all over 16 z raised to the power minus 2, right? So at the end of the day, this is going to be 2 minus. Now, when this one now comes out, if you look at this expression, you will see that this is cosine. It's coming from this place. It's coming from this place here. We'll see that if we multiply this one by 2, you'll be left with this one. So this is going to be cosine of cosine of pi all over 4. So that's going to be 1 all over 4, which is already there. 1 all over 4. Then 2 cos pi all over 4, right? So that's going to be there. Now the next thing here is going to be, this is 1 minus. So we can also factorize these ones too. Can factorize this. This is going to be 1 all over 4. So e raised to the power minus j pi all over 4. Then plus e raised to the power j pi all over 4. Z raised to the power minus 1. 1 all over 16 z raised to the power minus 2. So this is going to be 1 all over 2. So now you can see that this 2 can go out of this expression. So we have 2 here minus 1 all over 2 cos pi all over 4 z raised to the power minus 1 all over. Now this is going to be 1 minus, okay, 1 all over 4. And this is also going to be 2 cos pi all over 4. Z raised to the power minus 1 plus 1 all over 16 z raised to the power minus 2. So these 2 and 4 will cancel as well. So we are left with 1 all over 2, then 2 minus 1 all over 2 cos pi all over 4 is 0 raised to the power minus 1 all over 1 minus. So this is going to be 1 all over 2, right? 1 all over 2 cos pi all over 4 is 0 raised to the power minus 1 plus 1 over 16, right? Zero is to the power minus 2. Okay. Now, if we want these 2 to cancel out, we can bring out these 2. We can bring out 2 out of this expression so that we can free these 2 that is here. So let's go. Let's use another page. So from here now, this is going to be, so our h of z will be 2 coming out of this place so that we can see. I want us to see. So this is going to be 1 minus 1 all over 4 cos pi all over 4 z is to the power minus 1. Then 1 minus, this is going to be half cos pi all over 4 0 is to the power minus 1 plus 1 over 16 0 is to the power minus 2. These 2 will cancel these 2, and cos pi all over 4 is 1 all over root 2. We should know that cos pi over 4 is 1 over root 2. So from there, or root 2 all over 2, 1 over 2 or root 2 over 2. So it's going to be 1 all over 4. Cos pi over 4 is 1 all over root 2 or root 2 all over 2, right? So that's going to be 1 all over root 2 is 0 is to the power minus 1 all over 1 minus 1 all over 2 1 all over root 0 is to the power minus 1 plus 1 all over 16 is 0 is to the power minus 2. So this is going to be, so this is going to be 1 minus 1 all over 4 root 2 0 is to the power minus 1, then 1 minus 1 all over 2 root 2 0 is to the power minus 1 plus 1 over 16 is 0 to the power minus 2. So this is the eventual h of z. So this is the eventual h of z for this expression. Is the h of z for this expression. So now that we have gotten this h of z for this expression, so that is what they want us to get for this system. So the B part of the question says, is it possible? So let's go look at the B part of the question.